Alright guys, we're going to solve this quiz out. So remember there are two versions of the quiz, and I'll solve out both versions of them back to back. So if you really want to just see your quiz, you can skip ahead to see where problem 1 comes up again. Okay. If your question leads out with the cosine instead of the sine, you're on this version. Okay. The other question leads out with sine squared. Alright. So for this first question, it's very similar to the one that we did in the review. Right. We have to realize that this is going to be a Pythagorean identity. Right? We can say, hey, cosecant squared x is cotangent squared x plus 1. And if I plug that in, I'm going to get cosine squared x over cotangent squared x plus 1 minus 1. This minus 1 is this minus 1 right here. And this piece is what we replaced cosecant with. These two cancel out, and I've got cosine squared over cotangent squared x. Now we can continue to break this down further, right? If we change cotangent into cosine over sine, right? So we've replaced the piece right here with this piece. Now, we can continue to solve this problem by simplifying down. I'm going to end up getting cosine squared times, remember we flip this bottom piece when we multiply. I'm going to have some pieces that cancel out, and a final answer of sine squared. Okay, so that's problem 1, right? That one is pretty involved, but nothing too insane as long as you find this first identity. Okay, don't try to change this cosine though, right? If you change the cosine, then you're going to end up with a much longer problem. Okay, don't make that into either sine or secant. All right, let's take a look at number 2. So number 2, simplify sine squared x times cosecant squared x minus 1. Well, familiar, right? Hang on, that cosecant squared x minus 1, we already know that. That one is again the Pythag identity. That's going to be cotangent squared x, right? Just like we got up here. All right, so we could do the same exact work to find that that's cotangent. And that's being multiplied by sine squared x. Well, again, kind of, we're stuck. We've got elements that don't really mix together. So let's change them into sines and cosines, right? So cotangent becomes cosine over sine. Now notice these are squared, this is squared, so these are both squared as well. Now, if we take a second, when we're multiplying these, we know they're going to cancel out, so I can cancel out sine squared and sine squared there. And now, what am I going to end up with? Well, I'll just end up with cosine squared x. All right, so that's the first two, right? As long as you caught that same identity here and here, you could get to these answers. Again, don't try to change this sign. Otherwise, you're going to throw yourself off more. When you break these down, leave it alone because it's already in form of sine and cosine. Number 3 says, start by foiling this. We have secant plus 1 and secant minus 1, right? So if we start to FOIL these out, right, remember first, secant squared x, then we do the outside minus secant x, then we do the inside plus secant x, and then we do the last, which is minus 1, right? So again, negative 1 times positive 1 gives you minus 1, secant times 1 is plus secant, and then secant times minus 1, negative secant. Now, immediately it jumps out that these two middle terms are going to cancel out. Okay, and if you move downwards, you've got secant squared minus 1. That looks familiar, again, like one of my Pythagorean identities. Well, secant squared is tangent squared plus 1, okay? So if I use this and plug it in over here, I'm going to get tangent squared plus 1, and then bring this minus 1 down as well. Again, pieces that cancel, right? And I'm left with tangent squared. Okay? So again, I had to cancel those 1's out, and I got just tangent squared left. Now this is your final answer. Okay? All right, let's take a look at the back. So the back has the two verifying problems. So if we want to verify this first identity, okay, we have to remember that cosecant and secant are both versions of sine and cosine, right? So if I take this, and again, we're going to make these sines and cosines. So let's make a note of that. Make sine, cosine. Again, leave these top pieces alone, right? Those are already sines and cosines. We're going to leave those alone, all right? So if I change that sine theta over cosecant becomes 1 over sine theta, okay? And the second one is going to be cosine theta over 1 over cosine theta, okay? Now, in order to simplify these fractions, we're going to end up flipping this bottom one and multiplying it to the top, right? So I get sine theta times sine theta over 1, which is just sine squared theta, okay? This one, we can do cosine theta times cosine theta over 1, which then ends up being cosine squared theta, okay? So again, our steps are progressing downwards. These are going here. And then finally, I've got sine squared plus cosine squared. That's everyone's favorite identity. That's just 1, okay? So this identity, again, is that Pythagorean identity. I'll put it in right over here. Sine squared plus cosine squared equals 1. Super important, right? All right, so that's the first one. Again, flip these to sines and cosines, then they multiply together, and you end up with the two squares for your identity, right? We've got the last verifying one, cosecant squared x plus tangent squared x equals cotangent squared plus secant squared. Okay, so the good news is we have identities that somehow relate these, right? I can tell you that cosecant goes with cotangent and tangent goes with secant, right? You can check your identity page for that. You'll find those Pythagorean identities, okay? And let's write them out over here. Cosecant squared x equals cotangent squared x plus 1. And secant squared x equals tangent squared x plus 1. Okay, so watch what I'm going to do. I'm going to lead out with this one, okay, the cosecant identity, and I'll just replace it over here, okay? If I plug that in, this is going to become cotangent squared x, and we've got that plus 1, and this other piece will come down is still just tangent squared. Now, at least I've got this cotangent already, but this tangent piece now has that plus 1 with it, and I can use my other identity over here. Remember, that's equal to secant x, right? And I'll be able to get secant x from here. So now I'll have cotangent squared x plus secant squared x, which is the end result that I wanted here. Okay, so this proves that we're able to verify it. All right. So again, if you replace 1, then you can replace the other piece, and those 1s will end up canceling out. All right, let's take a look at the second version of the quiz. So, version B, this one very similar to the other question, but instead of sines instead of cosines, this problem has sines and secants. All right. So if we lead out, we can say this bottom piece is a Pythagorean identity. So let's take a look at what identity we can use with that. Secant squared x is tangent squared x plus 1. All right. So if I plug this information in for secant right here, sine squared over tangent squared x plus 1 minus 1. It's a pretty easy cancel right here. And I'm left with sine squared over tangent squared. All right, well, we've simplified it to a single term, and at least the denominator is condensed down. Now let's change everything into sines and cosines, okay? Again, we can leave this top part alone, right? I'll have sine squared x. And on bottom, we're going to have sine squared x over cosine squared x. Again, with these fractions, take the bottom one. We can flip that and multiply it. So sine squared x, that's the top, okay? That's the top. And I'm going to multiply it by this bottom piece that's been flipped over. So these will now cancel out. And I'm just left with cosine squared x. Okay, so again, we all start with this bottom identity, right? It's got that minus 1 on there. It looks like the piece that we should work from, all right? From there, it gets easier, right? The 1s cancel out. It's gotten smaller. Then we'll expand again a little bit into sines and cosines, then combine and cancel out, all right? Let's take a look at number 2. Number 2 is another one where we just need to remember one identity, right? It happens to be the same one I used up here. Secant squared equals tangent squared plus 1. So let's rewrite it. Tangent squared plus 1. So on this one, you could move it around and get that tangent by itself if you wanted, right? We can also just work from this secant, and that's what I'm going to do. I'm not going to try and overthink this and do too much algebra. Let's take this and replace it with tangent squared plus 1. So now I've got this first tangent squared minus, and take a look, that minus is going to have some parentheses behind it so I can catch this whole piece. All right. Now this minus sign is going to distribute in here, and now I can cancel these two tangents out. And I'm just going to be left with negative 1, okay? This problem is also on your review, okay? So pay close attention to that one. All right, let's take a look at number 3. Number 3, it says start by foiling, right? So let's go ahead and multiply this out before we get any further. So FOIL again, first, outside, inside, last. 1 times 1, 1, outside 1 times cosine. So we're going to get plus cosine x. Then we'll get minus cosine x. And finally, negative cosine times positive cosine, that's going to give me minus cosine squared x, right? Immediately, we can cancel. All right, and we've got 1 minus cosine squared x. All right, pretty good so far, but haven't finished yet. Have an identity that we can use here. Sine squared plus cosine squared equals 1. So you might notice that if I subtract the cosine squared over here, I'm going to get this as my identity. Let's note this as my identity. I get sine squared equals 1 minus cosine squared, which happens to be the piece I had right here. Okay, so what I can actually do is simplify that straight to sine squared x. And that's my final answer. Okay, so let's go through those steps real quick again, because I think I went a little fast on that. Okay, so we started by foiling, and then that canceled out these middle terms, and I got this piece right here, 1 minus cosine squared. Now this looks like one of my identities, so I said, hey, let me use this, and I'm going to move the cosine over by subtracting it. And I got sine squared equals 1 minus cosine squared. So I could tell you that this is just sine squared. Okay? All right, let's go to the back. So we've got cosecant over secant plus cosine over sine equals 2 tangent, right? And we're trying to verify this. So if we wanted to verify this, one key thing we might notice is this one is already a cotangent, okay? And that's based on that tangent and cotangent identities. So cosecant and secant, somehow we've got to get that to be another cotangent. Well, let's start out with making this into 1 over sine and 1 over cosine. And if you flip and multiply this and simplify it, you're going to get that this is cosine theta over sine theta. Okay? So we've kind of said break it down, flip and assemble them again, all right? Now, cosine over sine, we said that was cotangent theta, right? That's based on my tangent and cotangent identity. And then that's another one, so plus cotangent theta. Well, cotangent plus cotangent is obviously 2 cotangents, and that's my verified identity, right? So the complex part is right here. If you're not sure what I'm doing there, let's take an aside for a moment, and we will work that out. So that is 1 over sine times, remember we flipped this one, cosine over sine, over 1, which then comes out to cosine x over sine x, which was what I put down here, right? So that's if you weren't sure about that algebra. But again, break this one down, sines and cosines, simplify it, and then it basically turns out to be a cotangent. So this cotangent with this cotangent, so 1 and 2 makes 2 cotangent. Your identity has been verified. All right, we've got one more verifying, right? Again, it's an identity you can start from anywhere, right? As long as you realize tangent and secant are going to go together, and cotangent and cosecant are going to go together. So again, we're going to use the trig identities to replace these. So secant squared x equals 1 plus tangent squared x, and cosecant squared x equals 1 plus cotangent squared x. Okay, both pretty much the same thing. Let's put it together by plugging this in for one of these useful ones, right? So I'm going to start with this first one again. I'm going to make this secant squared x minus 1 equals tangent squared x, right? Again, I just moved the 1 over. So now I'm going to replace this tangent with this piece right here. So we've got secant squared x minus 1 minus cotangent squared x. So now we have to find a way to replace cotangent squared in here, right? So we can use the second of these identities, and I'll just use red so it shows up a little better. And if I subtract that 1 over this time, I'm going to get cosecant squared minus 1 equals cotangent squared. If you plug this one in here, secant squared x minus 1 minus cosecant squared x minus 1, right? And finally, I'll distribute, use a different color. So again, you're going to see these 1s that cancel out, and I've got secant squared minus cosecant squared. And that's kind of been the final result I was aiming for all along. Okay. Now this was one of those my verifying problems where they were pretty even on both sides. You could solve it from either direction. Okay. And you can set these identities up in multiple ways. I just chose one way to do it. Okay. So if you wanted to say, I'm just going to plug this in for secant 1 plus tangent squared, and I'm going to plug this in for cosecant 1 plus cotangent squared, that would absolutely work. Okay. And you might find that way easier. Okay. All right. So that wraps up the 2 quizzes, right? So 5 questions. They're all very similar. So if you want to practice one, why not look at the other version of the quiz as well? All right. Good luck.